Alright, I'm Nathan Armorest, and this is my presentation on unknown 48A. So, why do we want to find out what unknown 48A is? Because it could be dangerous, it could contaminate things, it could be toxic, it could be corrosive, we could use it to help us with energy, and so on. How are we going to identify it? With our IR and NMR spectra? Alright, so we're going to analyze it, and then when we're analyzing the IR spectra, we're going to look at this graph, and it'll tell you which we got from the lab manual. It's going to tell you where to look at if we find an OH at 3500 or 3100. We're going to be able to find that, and then also we're going to find the functional groups with the IR spectra. So if we find one from 3500 to 3100, then we have an OH right there. And then the NMR spectra, we're going to find the peaks and then the ratio by just looking at it. It's going to tell you right there. You see two peaks go up and down like that. And then the theory behind the IR and NMR, they're supposed to measure the amount of electromagnetic radiation absorbed. The IR is absorption of a photon in the infrared region, which leads to an increase in the energy of a molecular vibration, and that's to find functional groups. And then the NMR is an absorption of a photon in the radio frequency region, leads to excitation of a hydrogen nucleus, and that's for ratio and peaks. Here are the results. So for 48A, I found an OH right there, and then I also found a CH singly bonded. And then for the peaks, see there's two peaks because it goes up and down twice. And right next to the peaks were numbers, so that was 1 and that was 3. So my ratio was 3 to 1. Discussion of how I identified my unknown. So as I said before, I found the OH and I found the singly bonded carbon with hydrogen. And that's how I determined that, by looking through the table 1 that was given in the lab manual. And then after I looked at the NMR, and I found the peaks right there and right there. And then I found the ratio, which was listed right next to the peaks, which were 3 to 1. And after I gathered all that information, I was able to match it perfectly with methanol. Methanol in daily life, it's used for fuel, paint, carpeting, insulation, adhesives, all that stuff, etc. And then actually the good thing about methanol is a cleaner burning energy source, and about 40% of the world's methanol is used in energy related uses. And also it can be blended directly in the gasoline to create a more efficient gas. And there are my sources.